yesterday we started to talk at the end of the two topics that we did yesterday. We worked with multiplying a monomial times a polynomial, which had a lot of similarities to the distributive property. It really was the distributive property. And then towards the end of the lesson, we factored out a monomial from a polynomial. So we did that by finding the greatest common factor. Yesterday, what did we need to do in order to identify what the greatest common factor of this polynomial would be?
Breaking it out.
We broke it out. We broke out every term. So if I have 3x to the fourth, negative 9x squared, and a negative 12x, can I break out the factors of each of these terms? How could I rewrite 3x to the fourth to break out all of the factors?
3 times x times x times x.
Who can share how we could break out negative 9x squared? Leslie. How about negative 12x? Tamara, go ahead.
Negative 2 times 2 times 3 times 3 times x.
Check that again. Negative 2 times 2
Yeah,
times
3 times x.
times x. Good. Looking at how it's broken out, how would you identify the greatest common factor?
Oh, whatever number or x we all share.
Okay, whatever number or variable, whatever coefficient or variable they share. What do these share?
3.
They all share 3.
And
I can see that.
and
I
then
can circle it. And what else do they all share?
X.
And x. They all share this. Do they share anything else?
No.
No. So how can I write, what is the greatest common factor for this polynomial?
3x.
3x. Which means I can successfully factor out 3x from each term here. And we started with that yesterday. Now today, what we're going to do is we're going to fully factor this polynomial. It is half the battle to find the greatest common factor, but still we need to find everything else, what's left. Okay? So once we find the greatest common factor, we can actually factor it out. Just like distribution is a type of multiplication, factoring is a type of what? It's a type of division. We're actually going to factor or divide out a term so that we can successfully represent the remaining expression. Okay, so we're going to find the factored form, fully factored, meaning we're going to take the term out, but we're also going to represent what's left in the parentheses. This is really the opposite of distributing. And we'll go through that. So we're going to find the factored form of 4x to the fifth minus 24x to the third plus 8x. So let's first find the greatest common factor of each monomial, right? Each individual term here, we're going to find the greatest common factor. I skipped that. Okay, so we need to find the factors of 4x to the fifth, the factors of negative 24x to the third, and the factors of a positive 8x. Now, as you see these more and more, you're going to be able to factor without having to break it out. I recommend breaking it out early though because number one, you'll catch some little mistakes and it'll just get you a little bit more comfortable with the terms themselves. How can I break out 4x to the fifth?
4 times.
Samara, keep going, I heard you.
Oh, 2 times 2 times x times x times x times x times x.
Good. Michelle, how about negative 24x to the third?
4 times 4 times negative. Oh, we want to break it down.
Yeah, keep going.
Times 2.
2 times 2, which is 4.
Times 2 times 2.
4 times 4 is 16. Check your multiplication.
2 times 2.
We can break it down step by step to make sure that we don't make mistakes. What can I get to get 24? What can I multiply to get 24?
8 times 4.
Oh.
12.
Okay, we can do 12 times 2. 12 times 2 works, right? Other options, you could have done 8 times 3. You could have done 6 times 4. Can I break these numbers down further?
Yeah.
Yes. Which one can I break down further?
12.
12. how can I rewrite 12? 4 times 3. Good. Can I break this down any further? Yeah, what else could I break down?
4.
4 is actually the same as what?
2 times 2.
2, I'm going to put it over here. So you could have done that. And if you ended up breaking out 4 times 6, it would have been 3 times 2, and then 2 times 2. Yes, now, when we go through negatives, you don't have to make one of the numbers negative. Because, like, what might happen, imagine your only factor was a positive 2, and you only had one negative 2 here. I don't want you to think that that's not factorable. This really has a negative 1. So that negative can be represented as a negative 1, just so you're not thinking you're not able to factor something. You'll see examples of that when we go through some practice. Now, how would we break out the rest of the term? Good. And how about the last term? Good. 2 times 2 times 2 times x. So now, fully broken out, how can we identify the greatest common factor? Find what they share. Everything that they share. What do they all? Someone give me one thing that they share.
2.
They all share a 2. They share another 2 as well. And what else do they share? They share an x. So they share this. We'll just do the one on the end. And this. So what is the greatest common factor?
4x.
4x. 2 times 2 times x is what they share. And that's the same as 4x. Be careful. Oh, you said 2 to the second. That is what 4 is. So now, the greatest common factor is 4x. What does it mean to factor it out? What do we now, if we want to fully factor, what are we going to do with that 4x?
You can multiply that by whatever left of this number, because if you multiply that, that equals the original number we had, because that's the one thing we all share.
Okay, so that would be how to figure out what's left inside. If I said I want you to factor this, I want you to factor out 4x from everything in here, what are you thinking to do? A lot. You know what? It's so funny that you say subtract. A lot of students would say to subtract is to actually take it out. Are you subtracting it? Think about the opposite of distributing. When I distribute something, am I adding it?
No, you multiply.
No, actually, I'm multiplying it through. So if I'm factoring, while I am removing it, am I subtracting? No, I'm going to divide it out. Good. Okay, so now we have 2 ways that we can figure out what's left. Okay? One way is this. We can go back here. If I know, I'm going to slide this. If I know that my greatest common factor is 4x, I need to figure out what is left inside. So if I have greatest common factor is here, how do you think I could identify from the visual what would be inside?
Whatever's not circled.
Whatever's not taken out, where does it have to be?
Inside the
It has to be in. Right? Think about that. We're not changing the value here at all. So if I didn't take it out, then it's still got to be in. How can I represent all that is inside the parentheses for this term? X to the 4th. How about for the second one?
Negative 6x to the second.
Yeah, I forgot the little negative 1 here, so we'll just make that. Negative 6x squared. And then the last one? That is one way that you can figure out what's inside. For those of you who are just starting this and are getting a little bit more comfortable with factoring, I love this visual model because assuming you break it out properly, which you want to check, it really shows you not only how to identify what they share, but how to figure out what's left because it has to be everything else. Another option, if you don't want to do it a visual way, is to actually approach it by an individual term. So we can ask ourselves, if I have 4x, what can I multiply 4x by to get x, let me repeat. What can I multiply that greatest common factor of 4x by to get 4x to the 5th? So think about if I distributed, what would I distribute to end up with 4x to the 5th?
X to the 4th.
That would have to be and x to the fourth. That's another approach. We could do that same thing here. What would I multiply 4x by to get negative 24x to the third?
Negative 6x to the second.
Why is it negative?
Because
Why does the number inside have to be negative? I know a few things here. I know that my greatest common factor is positive, but I know that the term I'm trying to find is negative 24x. The only thing I can multiply a positive by to get a negative is a negative value. And then, what would I multiply 4x by to get 8x? A 2. Either approach is okay. For those of you that are a little bit more visual, the breakout is going to show you what it is. If you go this route, you're actually going to need to kind of backtrack it in your mind. So now we have 4x on the outside. We factored out the 4x, and what we're left with is x to the fourth minus 6x squared plus 2. How can I check to make sure that it is fully factored properly? We have a lot of ways to check, right? If we solve an equation, we can substitute our value back in. If we do a system, we have other ways that we can find the values. What would our check be here? To actually redistribute it. If I distributed, which is what we did yesterday, if I multiplied everything here, 4x times x to the fourth is 4x to the fifth. 4x times negative 6x squared, negative 24. X to the third, remember if I have the same base, I can add the exponents together. And 4x times 2 is 8x. If this matches, then I'm good. It makes sense. We can take it one little step further. Weird. Did that? We're going to try one before we go over one little, we're going to catch a mistake somewhere. But first we're going to practice. You can use this on your communicator. If you prefer to have it in your notebook as another example, you can. I know some of you like to keep some pretty decent notes here. So let's fully factor, which means if you are fully factoring, you are finding the greatest common factor and all remaining terms. For this expression, 4x cubed plus 8x squared plus 12. You can work on this together. You don't have to be in silence. Okay. If you want to show that entire line. Okay, you found what is shared. Okay, so that would be placed outside. Okay. So why is that outside? What do they share? Good. And then you can show everything left. Everything remaining. Think about how it laid out. If you distributed that greatest common factor to the whole thing, you end up with that. So how would it look? How would that polynomial look? Okay. You have a couple of options here. You could break out every term. 4x cubed, 8x squared. Well, girls, we shouldn't be talking. You're also being recorded. Anything you say and do can be used against you. I could break out everything. Okay? I have 4x to the third, so I could break this out 2 times 2 times x to the third. I could break out 8x squared. And I could also break out 12. To identify the greatest common factor from a visual representation, I can identify what they share. If I notice here they share this value. I didn't mean to circle that or cross it out. What do they share? 4 by 4. 2 times 2. Some of you may not have needed the visual. I look at this. Typically, we're trying to factor out a coefficient that is common and a variable that is common. Looking at the expression the way it is now, how do you know that an x cannot factor out?
Because 12 doesn't have an x.
Because there is no variable here. So they don't all share a variable. Okay. So my second step, if you want to call it that, you could look at the coefficients. Could you figure out the greatest common factor of the number 4, the number 8, and the number 12? Yeah, the greatest common factor there is 4. Some of you might be able to do that without a visual. That's fine. You don't have to use the visual if you don't want to. But if you use the visual, that does a few things for you. It not only, thank you, identifies your greatest common factor, it also tells you what's left. So what is left in that first term?
X to the third.
X to the third. What's left in my second term?
2x to the second.
Yeah, that's a 2. Sorry, I kind of erased it. And what's left in the last term?
3.
Now, for those of you that have trouble laying it out, think about your check. You're going to eventually distribute to something, and that's going to give you this as a result. So some of it is a little bit of visualization, picturing how to lay it out. This would result in that expression.
I know what video they're watching.
So I want you to take a look here. Joe factored this polynomial. I want you to take 3 minutes working together and identify 2 things. First, when Joe factored and he ended up with this, figure out why he's wrong. Figure out why he's wrong. And second, do it the right way. Okay, so Joe factored this polynomial, fully factored, he got this. Explain why he's wrong and show it the right way. So try to find his mistake first. Work together first in finding his mistake.
But are you still gonna be recording when we go on to like?
Well, I guess I was a double.
Show a thumbs up if you found his mistake. If you haven't found it yet, then you try to fully factor that expression, and then you might find it. The mistake. Who wants to share what Joe did incorrectly? Cece, go ahead.
He did his greatest common factor. He found the incorrect greatest common factor.
What did he miss?
He missed,
Squared.
yeah,
What do you mean?
x squared.
That was x squared.
Yeah, he found a factor. So for those of you that started by checking it and actually multiplying everything through, you would have ended up with 9x to the 6th plus 15x to the 4th plus 12x squared. But take a look here. Can you see something that they share that's still in there? Is there something in each term? Yeah, an x. There's still an x here. There's 3 there. And there's 5 there. You could have still taken another one out. For those of you that broke it out, you would have seen that they shared this. So you would have factored out 3x squared. And what would have been left inside?
3x plus 5x squared plus 4.
So it's tough to say that he was wrong. He wasn't completely wrong. He still did factor, but he didn't factor the greatest common factor. He only took out a common factor. So when you break it out, that will help you to prevent those little mistakes. Okay, so we are going to, this is not new. Let me start by clarifying that. I want to pause.